All right, welcome back to the deep dive. Today we're tackling a big one of the biggest bottlenecks in modern AV, really,
Yeah.
distance.
Mm,
We're diving into the source material for the DVI-Gear Hyperlight series, and specifically their DVI-25100 AOC cable.
right.
And our mission is to figure out the engineering magic that lets you push a full 4K 60p signal, that's 18 gigabits per second, across 100 meters with no signal loss.
It's an enormous hurdle. I mean, your standard copper cables, they give up long before that.
They just die.
They do. And the solution is right there in the name, AOC or active optical cable. And the performance they claim over that 100 meters is, well, it's astonishing.
So we're talking full HDMI 2.0.
Full HDMI 2.0, ACCP 2.2, deep color 4K video, not to mention full uncompressed digital audio. This isn't just, stretching a signal. It's delivering it perfectly.
So let's break that down, the active optical part. The secret here isn't just distance, it's that it's a hybrid cable, right?
Exactly. This cable isn't pure fiber, and it's certainly not pure copper. The actual video signal rides on light through 4 polyfluorinated optical fibers, or POF.
On light.
And that light path is what just completely eliminates the distance limits you see with copper wire.
Okay, but the sources say it still has 6 copper wires inside. So if they aren't carrying the video, what are they doing?
That's mission-critical stuff. That copper handles the power and all the low-speed control data, things like DDC communication.
The display data channel.
Right, the conversation between your source and your display.
Yeah.
It handles the EDD, telling the source what the screen can do, and critically, the HDCP handshake,
The content protection.
the content protection. Without that handshake, you get a blank screen.
And keeping that on copper has a huge practical benefit, which is power.
A huge one.
Mm.
Because the cable consumes such a tiny amount of power, we're talking less than a quarter of a watt, it can draw that directly from the connected HDMI source.
Which, for an installer, is a massive win. No bulky external power supplies.
In most applications, none at all. It just works. Okay, so distance is solved, but professional installs, they have another enemy, noise.
Yeah.
What happens when you put fiber in a building?
That's where the optical path really shines. Because the video signal is just light, the cable is completely immune to environmental noise.
RFI, EMI.
RFI, EMI, you name it. You could run this right next to a massive transformer or high voltage lines, and the optical fiber, it just doesn't care.
And if we connect that to the bigger picture, that low noise profile makes these perfect for really sensitive applications, doesn't it?
Absolutely. The materials point out that this is essential for places with strict security requirements. Think government, military, secure data centers.
Mission critical?
Exactly. You need flawless image quality, total dependability, and zero risk of the cable itself emitting any noise.
Beyond the raw performance, what I love is how much thought clearly went into the poor soul who actually has to pull the wire.
Oh, they did. You see it in the little thing, well, big things, like the plenum rating UL CMPOF.
Which is non-negotiable? It's non-negotiable for running cables through air handling spaces in, any commercial building.
And the flexibility.
The flexibility is incredible. A minimum bend radius of just 2 millimeters. I mean, think about routing that around a tight corner in a packed server rack. A copper cable would just kink and fail.
And the final genius move, those detachable HDMI connectors.
Yes. They reduce the whole cross-section down to about 12 by 10 millimeters, which makes pulling it through a narrow conduit so much less painful.
So when you put it all together for you listening, what we have is flawless 18 Gbp signal extension, 100 meters in tough professional settings.
And it simplifies power and installation at the same time. It's a really complete solution.
It's phenomenal engineering. But let's end with maybe the most incredible detail from the sources on just how rugged this thing is. This delicate-sounding optical fiber is engineered for an operating temperature range from a frigid -4 degrees Fahrenheit all the way up to a blistering 158 degrees.
It's a massive thermal swing.
A massive swing. So the final question for you to ponder is this. How do engineers keep those delicate optical pathways precisely aligned and keep the electronics functioning perfectly across 70 degrees of thermal change while light is flying through the fiber? That is the real physics problem to think about until our next deep dive.